Okay, here we go. So this is going to be part 2 of the solving systems of linear equations by substitution. Because there's 3 types of solution. There's the one solution where we have solved these. That's the part 1 video. Okay, so then we're going to focus on these two. I'm going to do one no solution and one infinitely many solutions, so that when you're solving those 10 problems on the worksheet, you can identify when you're solving, and when you realize like the x term went out or your equal sign is going to fail, then you know which one you have here. Okay, because you don't have to solve it all the way through. Once you recognize it, you can just stop from there. Okay, so no solution means that they are parallel lines. They're never going to intersect the 2 lines that are given. So what does it look like when you're solving? Your equal sign will fail, meaning it's not true. So what will happen is your x or your y term, once you combine or inverse operate your terms, the x variable or the y variable is going to cancel out. They're going to be opposite, so they're just going to go away. And so what you're left with are constants. And so 4 is not equal to 3, 2 is not equal to 0, -5 is not equal to 1. So these are just examples, okay? Infinitely many solutions, they're the same line. So when you graph them, they're right on top of each other. Okay, so what does it look like when you're solving? Your equal sign will be true. However, what you're going to see is because they're completely identical, you're going to end up with 0 equals 0, or you're going to end up with x equal x or y equal y. At some point, depending how you attack and how you decide to inverse operate, you end up with something like this. But if you take it all the way down, all the way to the end of solving, you're going to get 0 equals 0 on your step 4. Okay, so remember, we're still going to go through step 1 through step 5, but I don't have them written here. We're just going to go right into solving 2 systems. Okay, so no solution, our equal sign fails. Infinitely many, our equal sign is going to be true. Okay, all right, so let's solve this system. So we're going to go through step 1 through 5. Okay, so step 1 is decide between the 2 lines, which one do you want to isolate and which variable do you want to isolate. Okay, this is done for us. It's right here, right? Perfect. Yay, right? Okay, and so back to that identity property, everything is equal to itself. Here is y, here is y, right? Because everything is equal to itself. Y is equal to y. And so that's what allows us to substitute. Okay, so let's do green again. Let's make it look like the other video. So I'm going to take this expression and I'm going to put it right in there. Okay, so what do I get? 4, I'm going to put a parenthesis, equal 12x plus 3. But in place of that y, right, because y, get my hand out of the way, y equal this expression, and this is a y, I'm going to put 3x plus 1. And now you just clean it up, right? Okay, what's my first step? Distributive property, dp. So 4 times 3 is 12x. 4 times 1 is positive 4. And then I'm going to just carry down the equal sign on the right side, okay? Okay, so here we go. I have no like terms, no combining like terms. I know that probably looks like a D, but it's a C, and that's an L, and that's a T. I don't know if that helped. But no CLT. Why? Because my like terms are on opposite sides of the equal sign. Here's my equal sign. This is the left side. This is the right side. I have a variable term on the left. I have a variable term on the right. I have a constant on the left, a constant on the right. There is no combining like terms, which means I have inverse operations. Okay, this is what I'm going to choose. And since I'm recording it's what you guys have to see. Okay, so this 12x is positive, so I'm going to go ahead and subtract it and bring it right on over to the left side. Okay, so I get 0, right? And what do you know? 12x minus 12x is 0. So with these two special cases, I'm going to take it right up, but I'll bring it down, obviously, is it comes down to reading the equal sign at the end. Your equal sign here will fail. Your equal sign here will be true. So we don't have enough information yet. Now, if your eyes are jumping ahead, then yes, you already have your answer. Okay, so I have 4, I have my equal sign, and I have my 3. So now, is 4 equal to 3? No, my equal sign fails. 4 is not equal to 3. So when, oh wait, let me hold it, sorry. So when your equal sign fails, that means it's no solution, which means they are parallel lines. So in this case, it fails, so I have no solution. And that's it. You don't have to do any, oops, sorry, I apologize. You don't have to do any other work. That's it. It's no solution. There's no coordinate point to give me because there is no intersection, right? It's like the two lines are just moving like this. So there's no intersection point. And so that's why there's no solution, which means they are parallel lines. So that's it. Yay! Okay, second example. I told you this video will be way faster. It'll be way shorter than that 34-minute video. Okay, so this is solve the system. Go through step 1 through 5. And again, obviously, if we did a no solution on that example, we're going to get an infinitely many here. Okay? Okay, here we go. So step 1 is pick a line, pick a variable, isolate it. Okay, so in the third example, I told you, hey, you know, math teachers, we're efficient. We try and take shortcuts. We try and look for patterns, right? We're all about the less is more. This variable term has a coefficient of positive 1. I'm going for this one. So I'm just going to draw an arrow over here, and I'm going to isolate the x variable in that equation, which means if this is my equal sign, oops, sorry, wait, out of focus. Okay, I want to go in focus. Let's try and get something. Okay, this 2y is going to jump, and I'm going to wedge it right in between the equal sign and the 7. Let's have it. Okay, there we go. So I'm going to get x is equal to negative 2y plus 7. And remember, everything is equal to itself. So x is equal to x. So here's my x, here's my x. And so let's get the green marker. And let's take this expression, and you're going to plug it in right here. Okay, so we're going to go ahead and substitute it. Okay, so I'm going to rewrite the line, 3, but parentheses, plus 6y is equal to 21. But in place of that y, x, I apologize, I'm putting minus 2y plus 7. And now step 3, clean it up. By the way, step 2 is a substitution. So step 2 is, step 1 is identify, isolate. Step 2 is substitute it. Step 3 is clean it up, okay? So I'm going to multiply negative 6y, multiply plus 21, bring down the rest. Let's make sure I don't mess up. Okay, and so now we're cleaning up, and what do I have here? Combine like terms. Why? Because 6y and negative 6y are on the same side of the equal sign, right? Here's the equal sign. This is the right side. All of this is the left side. So they're both on the same side. So honor what you see. -6, +6. Those are opposites. So this is just out. And now look what you have. Constant 21 and constant 21. And is 21 equal to 21? Yes, everything is equal to itself. So this is a true statement. And so because this equal sign stands, you don't have a variable. There's nothing else for us to solve. I mean, unless you took, okay, you're done here, by the way. Okay, but because I had the 0 equals 0 right there, that's ideal, by the way. If you inverse operated, you get 0 equals 0. And so obviously this is the perfect, right? But this would get you your answer, and that's where you could stop. Okay, so this is in, oops, that's Y. Okay, that's an ugly E. Many solutions. Now, you could give me infinitely many solutions. You could even just give me many solutions. Okay. And that's it. That's your answer. That's it. Okay, so, whoops, sorry. So that worksheet that shows in part 1, those are still the 10 problems that go along with this video. It was just to show you the other 2 cases, because that 34-minute video was just showing 3 examples of one solution. These 2 are just to show you about the equal sign and what does it look like when you're solving. Okay, all right, thank you so much. These are long videos, so okay, see you in class.